Hey guys, this lesson is going to be an introduction to lesson 4.2, and our topic is adding rational numbers. For this lesson, you will need your math book, so make sure you have that ready because everything we do, you'll be writing in there. And then our learning target for today is that we are going to be able to find the additive inverse of a rational number and that we can add rational numbers. So that's what we're going to be able to do by the end of class today. All right, so a quick refresher, you guys can just kind of watch this one, but when we are adding fractions, in case you forgot how to add fractions, I usually like to write them going up and down. So you guys can see I'm rewriting this. And then you need to find a common denominator. So for 4 and 3, I need to think of what is the first thing they both go into. If you're not sure how to do that, I'm going to come over to the side. I might start writing by 4s. I might go 4, 8, 12, and then I'll start counting by 3s. 3, 6, 9, 12. First thing I get is 12. That's going to be my common denominator. Okay, once you get that, you figure out, well, how do I get from 3 to 12? Well, it's times 4, so I'm going to do the same on the top. 2 times 4 is 8. Then up here, I'm going to say, how do I get from 4 to 12? It's times 3, so I'm going to do times 3 on the top. I get 3 12ths. Now, when I'm adding, I get to add the numerators. So I do 3 plus 8, which gives me 11. And then I just keep the denominator. So 11 12ths. Your last step is that you just look and see, hey, can I simplify that? Well, nothing goes into 11 and 12 besides 1, so I am done. All right, so for the second one, we would do the same thing, except, just I want to do a quick refresher here, is we are going to change these mixed numbers to improper fractions. So to do that, in case you forgot, okay, if I have 2 and 4 fifths, I'm going to do the denominator, the 5, times the whole number, times 2, which is 10. Then I'm going to add the top, which is 14, and then it goes over 5. Okay, if I do the same thing here, I do 3 times 2, which is 6, and then I add the 1 on the top, which is 7, and then the denominator stays. Okay, then I could get a common denominator for 5 and 2, and I could add those fractions. So that's just a quick refresher on how to add fractions. So let's go ahead and open your math book to page 185, and this is where you're going to be doing your work. All right, so on page 185, we're going to talk about additive inverses to start with. Okay, so you guys know that two rational numbers are opposites if they're represented on a number line by points that are the same distance. So if you guys look at 1 here, -1, they're both one spot from 0. So those are opposites, okay? Same thing here, I have 3/4 and -3/4. Those are also opposites. They're the same distance away from 0. Those are opposites. Now, if you add two opposites, if I took 1 plus -1, you know the answer to that is 0. Same thing if I add 3/4 and -3/4, I know the answer is 0. Well, those are called additive inverses. That just means when you add them and they're the opposites, the answer is 0. So that's what an additive inverse is. One quick thing I just want to refresh your memory on too is a rational number. Remember, that's any number we can write as a fraction. So like 3, I could write that as 3 over 1. 0.4, that's 4/10. So again, we're working all with rational numbers this chapter. Okay, so if you stay on that same page and let's do example 1. It says find the additive inverse of -7/8. Okay, so it says graph and label a point on a number line that is the same distance away from 0 as -7/8. Well, that would just be +7/8. So I'm going to come over here, and here's 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8 would be right here. So I'll just put that point right there. That's +7/8. Okay, so those are additive inverses. So it says the additive inverse of -7/8 is 7/8. All right, if you flip to page 186, this shouldn't be difficult. It says find the additive inverse of -1/8. So what could I add to -1/8? That would give me 0. So -1/8 plus something is 0. Well, its additive inverse is +1/8. Because if you put those together, if you add them, you get 0. All right, let's go to page 186, example 2. I'd like you to take a second to read through the problem for example 2. All right, it says Annalise earned $36.82 at her part-time job and she earned $18.50 babysitting. Okay, so it says find the total amount she earned, the additive inverse, and describe a situation so that Annalise ends the week with $0. Okay, so we have kind of 3 things to do. So it kind of split it up for us. So part A, it says find the total amount that she earned. Well, you guys kind of know this. Let's come over to the side. She started with $36.82 at her job, and then she earned $18.50. So I want you to write this right in the margin of the book, just like I'm doing. Okay, when you add decimals, you have to line up the decimals in case you guys forgot, and then just add straight down. So 2 and 0 is 2. 8 and 5 is 13. Carry the 1. 8, 6, and 5 and 1 is 15. Okay, and then 3, 1, and 1 is 5. So, and then I'll drop my decimal straight down. So she made $55.32 that week. Okay, there was our first question. Okay, let's go to part B. So part B says, well, find the additive inverse of that number. So if my number is 55.32, what number can I add to that to get 0? Well, it would have to be negative $55.32. That's what I could add to it to equal 0. Okay, now it says part C, describe a situation so that she could end the week with $0. Well, if she made $55.32 this week, how could she end up with $0? Well, there's a lot of things she could do. She could lose it, okay, because that would be negative $55.32. She could spend $55.32. Okay. Now, look at the last ones. There's one more choice that would be correct. So I'll give you a second to read through it. Okay, if she donated it, she also would be getting rid of the money. Finding it would give her more money. Getting a gift would give her more money. Earning would give her more money. And so those 3 would be what she could do to end up with $0 for the week. All right, I would like you to pause the video and go to page 187 and try the check. Okay, so I want you to try part A, B, and C kind of without my help. When you're ready to see the answer, you may push play again. Okay, so this time the question says Zoe spent $12 on a video and $25.82 on a poster at the music store. Find the total amount she spent, the additive inverse, and then describe a situation so she ends up the week with $0. All right, so first you guys need to figure out, well, how much did she spend? Well, it looks like she spent $12 and $25.82. If I add those, I'm going to put my decimal here. I'm going to say 82 cents, 7, 37. So she spent $37.82. Okay, now if she spent it, I'm going to say that's like a negative. All right, now what's the additive inverse of the total? Well, if she spent $37.82, the inverse would be positive $37.82. Now, I want to know what describes the situations that she could end with $0. Okay, so if she's kind of right now, she's in the hole $37. She spent it. She needs to earn $37.82 to get her to 0. So it looks like part A is where she would earn that. It cannot be B because she's spending money. This, she's spending money. If she got a $35 gift card, that would be earning, but it's not enough to get you to 0. So that one's also not correct. All right, so the next part of our lesson, we are going to actually be adding rational numbers. So we're going to try to figure out if I have a mixture of decimals and fractions, how can I add those? That's what we're going to learn how to do today. So I'll give you some clues to kind of help you figure out what to do. So first thing, if you guys look over at the talk about it, why would it be difficult for someone to add negative 2.5 and 3.16 and the 6 or the 6 is repeating? Just think about that to yourself for a little bit. All right, this would definitely be difficult to add because that number just keeps going on and on forever. So this would be a little bit difficult to add. So here are some little tips for when you are adding rational numbers. Okay, if you have decimals that are nice, that end or terminate, like 0.8 or negative 0.2, it's easier to change fractions to decimals and add. Okay, now if you have decimals that repeat, it's easier to change those or keep them as fractions and then change the decimals to fractions. So again, we'll kind of talk about that. The last thing I want to talk about is if you had this fraction, negative 2/3, that negative sign can really be put anywhere. It could be put on the top of the fraction, like that, or it could be put on the bottom of the fraction. You just kind of use it one time though. When we're adding today, it's going to be easier if you just kind of put it on the top of the fraction with the numerator. All right, let's go to page 188 and try this one. Okay, now I'm going to have you guys work this out on the side, so you can do it over on the lined area on page 188. So here is our problem. We are going to add these two fractions. You've added fractions before, so this is nothing new. The only new part is adding the negative sign in front. So here is what we do to add these fractions. Okay, I'm going to come do it over here. Negative 3 5/9 plus 1 2/9. Okay, so when you are working with mixed numbers, the easiest thing to do is to change them to improper. So when you change it to improper, okay, let's do the bottom one first. I'm going to do 9 times 1 and then add the top. So I get 11 over 9. Okay, now on the second one, I just need to tell you guys this. You need to ignore that negative sign when you change it to improper. So it's kind of like I cover that up and I just do 9 times 3, which is 27, and then add 5, which is 32 over 9, and it's negative. So again, you kind of ignore that negative sign when you're doing the 9 times 3 plus 5. Okay, now next step is you need to look. Do they have common denominators? Well, looks like they do. They both have 9, so that's nice already. So my denominator is going to stay a 9. I'll just write that over here. Now all you have to do is add the numerators. I'm doing negative 32 plus 11. Now if you forgot how to do negative 32 plus 11, it's what do you have more of? I have more negatives. How many more? I'm going to do 32 take away 11, and I end up with 21. So my final answer is negative 21/9. Now the next thing you should do is you should always check and to see if I can simplify this. I can actually divide this down. 3 goes into both of those. So if I divide it down by 3, 9 divided by 3 is 3, and then negative 21 divided by 3 is negative 7. So my final answer is negative 7/3. Okay, so that's one answer. Now you could also change that to an improper fraction. So if I do that, I might do 7 divided by 3. Okay, 3 goes into 7 twice, which is 6. I'm going to subtract. I end up with 1 left over. So it's 2 and 1, and then keep that denominator, third. And this was negative still. So or negative 2 and 1/3 are my solutions. All right, I'd like you to pause the video and try the check on the bottom of page 188. So try that out using the method I just showed you. All right, if you try this one out, I'm going to rewrite it going up and down first. That's how I like to do it. Then my next thing I'm going to do is change these both to improper. And right away, I know they're both negative, so I like to put the negative sign. All right, so I'm going to do 3 times 6. Again, ignore the negative sign. 18 plus 1 is 19 over 6. Over here, I get 12 plus the 5 is 17 over 6. Okay, now again, it's still an addition problem. So if you guys are looking at this, you're adding two negatives. So you get to combine them. So you just get to put those together. So I've got negatives and more negatives. I still have negatives when I add. So my answer is negative. Keep the denominator. And now I'm going to add 19 and 17. Okay, so if I do that, I get 36, it looks like. So I have negative 36 over 6. Now you might think, hey, I'm done. Okay, but it looks like I can divide that down. I think 6 can go into both of those. So I get a 1 on the bottom. I get a 6 on the top. It's negative. So negative 6 over 1, which again, that's just the same as saying negative 6. 6 divided by 1 is 6. So my final solution for this problem is negative 6. All right, let's go ahead and try example 4, which is on the bottom of page 188. So same thing, I'm going to do this over on the side of the page. So I'm going to do 1 3/4 and plus negative 1/6. Okay, so first thing I'm going to do is change the top one so it's improper. So I'm going to do 4 times 1, which is 4, and then add the top, which is 7 over 4. Okay, now I need a common denominator for 6 and 4. If you forgot how to do that, count by sixes, 6, 12, 18, and count by fours, 4, 8, 12. Ooh, look at 12 is the first one that comes in common. So my common denominator is 12. Okay, now I've tried to figure out from here, how do I get from 6 to 12? It's times 2. So negative 1 times 2 is negative 2. On the top, I do 4 times 3 is 12, so 7 times 3 is 21. So now, here's what I have. I have 21 over 12 plus negative 2 over 12. Now, I just get to add the numerators. So 21 plus a negative 2. Well, it looks like I have more positives. So my answer is positive. 21 take away 2 is 19. And then it's going to go over 12. So my final answer is 19 over 12. It doesn't look like I can simplify that at all, so I can just keep it like that. All right, I would like you guys to try the problem on page 189, the check. So pause the video and please try this out. All right, so first thing you guys should have done was change these to improper. So I'm going to do 3 times 3. Again, ignore that negative sign. Plus 1, that gives me 10 over 3. And I'm going to put the negative on the top. Over here, 5 times 4 is 20. Plus the top is 21 over 4. Okay, now you guys need a common denominator for 3 and 4. Again, if you're not sure how to do that, you go 3, 6, 9, 12. Count by 4s, 4, 8, 12. First thing they have in common is a 12. So I'm going to make the denominators out of 12. So now from 4 to 12, it's times 3. So I need to do 21 times 3. If you're not sure how to do that, or you can't do that in your head, you just come down here and do 21 times 3. 3 times 1 is 3. 3 times 2 is 6. So it is 63. On the top one, I'm going to do 3 times 4. And then negative 10 times 4 gives me negative 40. Okay, so finally, here's what I have. Negative 40 over 12 plus 63 over 12. Okay, so now I am going to add my numerators. I have negative 40 plus 63. Okay, so if I look at that, I have more positives. So I know my answer is positive. How many more? I'm going to do 63 take away 40, which looks like it's 23. So my answer is 23, and your denominator stays as a 12. If you guys look at that, there's nothing that goes into both 23 and 12. The last thing you guys could have done was change it to a mixed number. So if I did 23 divided by 12, it only goes in there once. I'll subtract 12. 3 minus 2 is 1. 2 minus 1 is 1. So there's 11 left over. So it would be 1 and 11 twelfths. So you could have written it like that as well. I would accept either of these answers, but it has to be positive. Please make sure to ask questions if you don't get something. Hopefully you know what an additive inverse is after this lesson, and you can add rational numbers. Now, we didn't really do any fractions and decimals, but we will do that on Monday. So for now, we were just adding positive and negative fractions or positive and negative decimals today. All right, so for the rest of class, I would like you to try page 195, problems 1 through 9. Just get as far as you can during class here. Make sure you show your work.